Okay, so let's talk about slope.
Do you think I should use a pen or a pencil?
Let's just talk about slope.
I only have a pen.
That's fine. Okay, slope. Listen, please. These shouldn't take me long to get through. We're going to be finding the slope of a line from a table, from 2 points, and from a graph. And today, your worksheet has them all kind of jumbled together. So, from a graph, I personally think might be the easiest because there's really no math really involved. If you can count, you can find slope from a graph. So when looking at a graph, this graph is kind of tough because you can't really see the points really well. It didn't print out very well, but it looks like there's a point right here and a good point right here. And when I say good point, you want to pick points that your line is crossing through, like an actual number or one of these, or on the corner of one of your coordinate plane. So like here's 2 points. It didn't print very well. Here's 2 more, it looks like. But when you are finding slope, you only need 2 points. Once you've identified those 2 points, then what you do is you figure out the rise over. It's rise over what?
Run.
Oh, you do know slope.
No.
I just tricked you into that one.
I didn't say anything.
Rise over run. Okay. So rise means how much do you go up or down. Run is how much do you go left or right. Now you're going to get really sick of me saying this, but you read graphs exactly like you read a book. So you read books from left to right. So when you look at this graph from left to right, it is going up. So because it is going up, that means that you are going to have a positive slope. So again, when you are looking at your graph, and if it's going from left to right, if it's going up, that means your slope will end up being positive. So you don't need to actually figure out what this coordinate is and what this coordinate is. You're going to figure out, I'm only going to use 2 of them. So these 2. How much do I rise from this to this? And then how much do I run from this to this? So I'm going from left to right. So I go up 1, 2, 3. So I go up 3. So 1, 2, 3. And how much do I run? 2. 1, 2. So it's 3 over 2. Now, the one thing that I will tell you is you need to leave your slopes. Please follow along. Your slopes have to be fractions because this represents how much you go up or down. This represents how much you go left or right. So leave it as 3 over 2. Let's say you forget and you get a 1.5. Well, if I ask you, well, what's that mean for slope? That means you're going to go up 1.5 over 1, and that's kind of weird, so you don't want to do that. 3 over 2 is 1.5, but I don't want it as a decimal. I want them as fractions. So if you have a graph today, when you are doing your slope, rise over run. Now, let's say you had to go down, that would be negative. If you have to go to the left, that's negative. Because we went up and to the right, up is a positive direction on a graph, right is a positive direction on a graph. Okay? Do you kind of remember that?
Yeah.
Okay, there we go.
I don't remember
There we go, rise over run. Okay, from a table. I think a table is the easiest one as well. So, and honestly, you're going to see me not even I probably will show you the slope formula, but you're probably never going to use it again because I'm going to show you how to do it with points like we do the table. So when you are looking at actual numbers, actual coordinates, you have to figure out the change in y over the change in x. So because we do rise over run, rise is how y changes, over run is how x changes. So you would need to put the y change on top. Bryce, please pay attention. Y change up top, X change on the bottom. And you really only need to go between 2 points. Just like on the graph, we only need to look at 2 points here. So you can pick your favorite two. It doesn't matter. So I'll look at these top two right here. We have to figure out, how does Y change? If I go from 22 to 16, how does Y change? Plus 6 or minus 6? Minus 6. If I go from 22 to 16, I go minus 6. And if I go from -4 to +2, how's that change? You have a question, yes.
With the tables, wasn't there my teacher was talked about how there was like a table that would go it would go 2, 4, but then it would skip to
Yes, that's why you only pick 2. That's why you pick 2. Only 2. Please put your mask on. So that's why if your mask, I'm all focused on masks. If your table doesn't go up or down by the same amount, that's where it gets a little tricky. So you do want to pay attention only to 2 of them. So for my Y's, if you go from 22 to 16, you go down 6. And for my X's, if you go from -4 to -2, how does that change? +2. So change in Y is -6. Change in X is a +2. So now you can reduce this. And if we're taking multiple choice tests and quizzes, which you saw yesterday, I can promise that they will not leave it as -6/2. What would they write this as? -3. So you got to figure out, how is Y changing? How is X changing? Write them as a fraction. And then if it can be reduced, I would highly recommend reducing it. So that's how you do the table. So for a graph, you do rise over run. See if it can be reduced. Maybe it can, maybe it can't. This one can't be reduced. You want to leave them as a fraction. Now, like this one reduced down to -3. You could write this as a fraction if you really wanted to. How do you write -3 as a fraction? -3 over 1. So you'll have to keep that in mind when we get to graphing, but that's not until after we get back from break. The last way that you're going to have to find slope today is between 2 points. Now, there is a formula, the y2 minus y1 over x2 minus x1, that I'm sure you've seen before. Do you remember what letter they used for slope? It's like not a letter that's even in the word slope. What letter?
Y? No.
M. Good. It's M. B is y-intercept. We will be dealing with B. M is what we use to represent slope. The slope formula, if you want to use it, you absolutely can. I think it's going to take more time to use the slope formula. It's y2 minus y1. Change. How do your y's change? Over x2 minus x1. So if you want to plug into that formula, if that's your comfy spot, go for it. I'm going to show you a different way to do it. So if I take my two coordinates, 2, -3, 5, -4, and I'm going to stack them. And I'm almost going to stack them like they're a table now. This is kind of a little shortcut for you. So if I stack them like a table, now I can do what I did here to find the slopes. We have to figure out, how do the y's change and how do the x's change. So if I go from -3 to -4, what do I do? How do I get from -3 to -4? Subtract 1. So -1 over, how do my x's change? +3. So -1 over 3. And that cannot be reduced anymore. So that would be my slope. So instead of plugging into the slope formula, you can do the exact same thing that you did with the tables. Do you see that? I used to teach the formula and really get into the formula, and then one kid one year was said, well, can't we just do like what we're doing over here? And I was like, yes. I don't know why I even bothered with the formula before, because this makes more sense and it's faster. Especially if you're a visual person and can see it. So let me get your little assignment out to you. I want to walk through maybe a couple more. Or do you think you need more? Okay. So for those who are still paying attention, number 1 is a graph. When you are finding the slope of a graph, you just pick 2 points. They give you 1, 2, 3, 4, 5 of them. You just need to pick 2 and kind of focus in on those. So I'm going to focus on these 2 right here. These 2 little guys right here. You could focus on these 2. You could focus any 2. I like dealing with ones that are on the axis. I don't really know why. I like them. So when you're finding the slope between 2 points on a graph, you have to figure out the rise over the run. So how much do you go up or down? And how much do you go left and right? Or right? So if I start here and I go to here, I move from left to right. Is my graph going up or is this graph going down? Down. So because it's going down, because remember you read graphs like you read books from left to right, because it's going down, that means that I will have a negative slope. So when it's all said and done, you should have a negative out in front. So if I go from here to here, I go 1, 2 down, -2 over, and then I run 1, 2, 3, 4 to the right. So I went down 2, right 4. So if I have -2 over 4, what does that reduce to? Because you don't want to leave it like that. Those that have already ahead of me, what do you have as your slope? That wouldn't be right. What's -2 over 4 reduced down to? I'm about to make it so you can't listen to music while in this class anymore because people are not paying attention. -1/2. -1/2 is what this would reduce down to.
I thought you were saying -1/2 over 2. And I was like,
No. -1 over 2. Good call. So notice I didn't use these other points, but if you were to pick any 2 points, once you reduce it down, you will get a -1 over 2 for your slope. Let's take a look at another table. So when you are dealing with the tables, you have to pick 2 points. So I'll just always pick the top 2. Figure out how is y changing, how is x changing. So y goes from 2 to 2. So how does y change? 0. And then from 3 to 1, -2. So my slope is 0 over -2, which is what? What's 0 divided by -2?
-2.
0. Trust calculators.
Looks like I'm stupid.
Trust calculators. 0 divided by -2 is 0. And lastly, before I let you loose on the rest of this on your own, if you are given 2 points, I would recommend doing kind of what I showed you in the notes. I would stack them. And then I would do the same thing that I did over here with the table. So I have to figure out how do my y values change. So if I go from 7 to 5, what's that? -2. So -2 goes on top. And then if I go from 3 to 9, +6. So -2 over 6. And that reduces down to -1 over 3. So there's 6 examples. The rest of them, try them out, see how you do.